Now let's see another interesting question asked. Consider the following compounds in the liquid form. You can see that it is being mentioned not in the gaseous form. So this has got nowhere related to the dipole moment, whereas a charged comb is brought near to the flowing stream of these liquids. How many of them are deflected? You know that this leads to what? The charge on the comb, and if this drop is getting attracted, that means only the polar species gets attracted. Polarity means net dipole is not equal to 0. Now we can see that you have got few of the species which are being mentioned. You need to draw their shapes so that you can know if there is any cancellation of the dipole. Alright, you should know how to write these shapes, isn't it? CHCl3, then you have benzene and chlorobenzene. So all these species are given. Now you can see that this O2, because of the double bond and similarity between these two, is non-polar. HF, there is clear-cut electronegativity difference. Polar, you know that this doesn't get cancelled because of the bent shape. Presence of lone pair makes it what? Bent. So dipole moment doesn't get cancelled. You know, over here also lone pair is making it pyramidal. So dipole moment doesn't get cancelled. There is a resultant dipole moment, isn't it? Is also polar, and this anyways out of plane, so this is polar, this is polar, this is non-polar because all the species are identical, and this is also polar. So you can see how many of the species are getting deflected. That means polar species are how many? You can see 1. Alright, polar species you need to count. So total number of species that are getting deflected is 6, that is polar. Now let's see the next question. The easy questions, isn't it? Relatively easy. Based on the bounds of 15th group, the correct statement are asked, right? So this is about the basic strength. Option A, if you see carefully, B2O5, bismuth is a metal and a nitrogen is non-metal. You know that metallic oxides are basic in nature. You know, N2O5 and dissolved in water gives rise to a very strong acid, that is HNO3. Therefore this is acidic, isn't it? So this is by nature what? Acidic, and this is basic. So option A is correct. Now check out option B. NF3 is more covalent. You see, whenever you are making the comparison, you should see the uncommon part, isn't it? You can see NF3 and BiF3. So common here is fluorine. So I'll ignore fluorine. And you know, fluorine is more electronegative, it gets minus charge, hence nitrogen gets +3 and bismuth also gets +3. So the charges are also same, but only one factor which is differing for these two is nothing but what? Size. Nitrogen size is less than that of bismuth. So in case of the cations, from the Fajan rule, right? Fajan also, more the size of cation, it is by nature what? Ionic. Therefore BiF3 is ionic, NF3 is covalent. Makes sense? Now, PS3 boils at lower temperature than NF3. Yes, absolutely, because you know, you have studied so many times that there is possible hydrogen bondings in ammonia but not in PH3. So boiling point of NH3 is greater. The NN single bond is stronger than PP single bond. This is absolutely wrong. You know that not only in this case, but in many cases like fluorine, you know that the lone pairs are not making it stabilized, right? You know, the presence of the lone pairs will make it unstable. There is a possible repulsion, isn't it? However, when the lone pairs are present with the bigger atom, you know that they will mutually get compensated by forming p pi d pi back bonding, right? So that's why when you compare the bond energies of the second element with first element with their homonuclear species, you know that second element will form a stable compound, right? So right answer will be Cl2, and here also P2 will be more stronger in bond comparison to N2. All right, so this is wrong statement. So right answer is A, B and C.